In this video, we're going to talk about active filter. Now, in the previous handful of videos, we've talked about passive filter. So if you recall, passive filters were designed using R, L, and C. So passive filters are built with R, L, and C. These are all passive devices, therefore are called, what we build with them is called passive filters. Now, we can also build filters out of op-amps, and there are earlier videos that you can watch that introduces you to op-amps. And if you recall, we discuss in some detail these ideal op-amp model, and that same ideal op-amp model allows us to do analysis on these filters that we're going to build with op-amp. The only passive components we need when we are doing using op-amps are R and C. So if you notice, L is eliminated, and if you want to think about that and think about it that way, they're replaced with op-amps. So these ideal op-amp allow us to build what we call active filters. And the active filters have a number of advantages over passive filter, and that's why in many cases we will move to implement active filters instead of the passive filter. Let's talk about the three main benefits that we get from using active filter instead of a passive filter. So the number one is, even though that might sound simple at this point, is they have no need for inductors. Inductors are expensive from just a pure material they consume, as well as they're heavy. They're not highly reliable. They vary depend on what point of operating point that you're applying, number, frequency, amount of voltage you're putting together. So not having no need for inductor is a real advantage for active filters. So here is a benefit for active filters. The second benefit for active filter is that it allows you to have a gain of larger than 1 because you're using active devices and can amplify things. So therefore the magnitude of H of S is no longer limited to 1. Really kind of you are basically limited by the open loop gain of the op-amp. For example, even a cheap simple LM324 has an open loop gain of 10 to the power of 5. Of course, that's at low frequencies, but nonetheless, it's got a pretty large open gain. So we can actually make our HFS to be larger than 1, where in passive filters, we were limited to being 1 or less. And then the last one are also very, very important. That is, if you build a filter, okay, and this filter is an active filter, two things are true. One is, since you're using op-amp, your input impedance, as you measure your at the input, measure the impedance or resistance, let's call it impedance, let's be general. Impedance on the input is very high, okay? And then the other benefit is that the output impedance, as you're looking at the output, the Z of out is very small. So why is that an advantage? That is an advantage. So when I'm trying to hook up these filters together, or I want to add another device to it, since Z of out is very small, I can get away with putting a Z out here, Z load on this, without changing the behavior of the active filter. On the other side, since the input is very high, I can cascade them. So the next filter is going to have a Z in, which is going to be the Z load to the first filter. And because Z of in is high and Z of out is low, it will not change the behavior of the filter. So what I'm basically talking about is if I've got this, and for example, we are using, again, going back to LM324, the Z out, when we're looking at the output of this, the Z out is somewhere around 75 ohms or so, okay? And then when we look at the same device, Z in is roughly around 2 mega ohm. So now if I come and put another filter here, I'm going to have 2 mega ohms in parallel to 70 ohm, which is basically 75 ohm. So the characteristic of this filter will not change, its cutoff frequency will not move significantly, and all of that. So these are the three benefits: capping, no inductor required, the gain is large, can be larger than 1 if you wanted to. And then the third benefit is the fact that the input impedance and the output impedance is very large, output impedance is very low, therefore we can cascade these or put things on back to back without affecting the previous op-amp, previous filter or op-amp or whatever. So now in the future, as we work with these filters, as I mentioned, we can model op-amp using ideal op-amp. And as just a refresher, ideal op-amp model basically say that the gain, you can assume the gain, open loop gain, is infinite. You can assume that IN, the I coming into I coming to the negative side is equal to I coming to the positive side. So this is IN, this is IP is equal to 0, and again the voltage VN and the voltage VP equals to VN. It's not equal to 0 necessarily, but these are the three conditions. Using this, we can build low pass filter, build high pass filter, then use them to build band reject and band pass filter.